2.7 Absolute Value Inequalities. But in this sections, we will also talk about absolute value equations. Okay? So absolute value equations, we saw that in elementary algebra. That's basic absolute value of a number. It basically means the distance from 0 to that number. So if I say absolute value of x is equal to 3, that means we have these 2 points as our solution because the distance from 0 to 3 and the distance from 0 to -3 have the same distance. So that will be our, excuse me, our solution. So it is very important that you apply the definitions of absolute value correctly. So absolute value equations, key thing is first you need to isolate absolute value by itself on one side and a number on the other side. Then you can write equivalent expressions saying that the expression inside the absolute value is equal to k, or expression inside the absolute value is equal to -k. So let's take a look at on the first example, right? So for example 1, I cannot apply definition of absolute value right away because I have not isolate the absolute value itself yet. So first stop, we have to add 1 to both sides so that it will be absolute value by itself on the left hand side and a number on the other side. Now I can apply the definitions of absolute value, which is tell us 3x minus 5, that is equal to 7, or 3x minus 5 is equal to -7. So it is important to write down or because remember or is basically means the union, right? So it will be the answer that coming out from both cases. So now after that, all we have to do is solve each equations. So as usual, adding 5 to both sides, that gives us 12. Then divide by 3 to both sides, which is x is equal to 4. Then on the second equation, you add 5 to both sides, that'll become 3x is equal to -2. And then divide both sides by 3, which is x is equal to -2/3. And that is our final answer, which is -2/3, 4. Two solutions that we get. Now, second example, and this time it is what solving equation with 3 times absolute value of x minus 4 minus 4 equal to 8. So first we need to isolate the absolute value itself. So add 4 to both sides. That will become 12 on the right hand side. And then we divide both sides by 3. So this gives us absolute value of x minus 4 is equal to 4. And finally, we can apply the definitions of absolute value, which is rewriting equivalent statement that tell us x minus 4 is equal to 4, or x minus 4 is equal to -4. Solving each case, on the first equations, when you add 4 to both sides, that will become x is equal to 8. On the second equation, when you add 4 to both sides, that will become equal to 0. So my final answer is 0, 8. And sometimes when you solving absolute value equations, you have absolute value on both sides. So how do we take care of that situation? Okay, it's very simple. Treat one side as a number. So meaning you have to decide which side you want to apply the definition, equivalent definition. So for example 3, I will apply the definitions of absolute value on the left hand side. So the right hand side I will treat it like a number. So 7x minus 3 is equal to 3x plus 7, the original number, right? Or 7x minus 3 is equal to negative of the original number according to the definitions, plus 7. Now I solve each case, so it's very straightforward, right? So subtracting 3x on both sides, that will give me 4x minus 3 is equal to 7. And adding 3 to both sides, that give us 4x equal to 10. And dividing both sides by 4, which give us x is equal to 10 over 4. And simplify it, which is 5 over 2. Okay. Now, second equation, 7x minus 3 equal to distributing negative sign. So that gives us negative 3x minus 7. Adding 3x to both sides, which gives us 10x minus 3 equal to negative 7. Adding 3 to both sides, that gives us 10x is equal to negative 4. And finally divide both sides by 10, which is negative 4 over 10. Reducing it, that gives us x is equal to negative 2 over 5. So now I have two solutions. One is negative 2 over 5, and the other one is 5 over 2. So very similarly, this example 4, we can do the same one. Right? So treating one side of equation like a number. So as usual, I'm gonna treat the left hand side. I'm gonna apply the definitions on the left hand side, so it will be 6x minus 5 is equal to original number 3x plus 4, or this looks like a 6, or 6x minus 5, right, is equal to negative of the original number. So solving in each case, adding 3 to both sides, that will become 3x minus 5 is equal to 4. Adding 5 to both sides, 3x is equal to 9. Dividing both sides by 3. So therefore, my x is equal to 3. For second equation, First, we distribute a negative sign, which is 6x minus 5 equal to negative 3x minus 4. Adding 3x to both sides, that will become 9x minus 5 equal to negative 4. Then add 5 to both sides, which is 9x is equal to 1. And dividing both sides by 9, that gives us 1 over 9. So my answer is 1 over 9 and 3. So that is solving equations. So now let's take a look at on solving inequalities, absolute value inequalities. Okay? You have to remember two cases. Absolute value of uh, absolute value inequality with less than symbol and absolute inequality with greater than symbol has two different equivalent statements. So the reason is why is this. We know that if absolute value of x is equal to 3, that means we have two answers right here, 3 and negative 3. Now we are interested in when the absolute value of x is less than 3, that means the distance must be smaller than 3. So I cannot, the x value cannot be greater than 3. It must be somewhere in between right here. Okay. Or on the left hand side, the x value cannot be greater than negative 3. Right? Smaller than negative 3. So it must be what? Right here. So that way, from 0 to here will be the distance will be smaller than 3. From here to there will be smaller than 3. So that makes the equivalent statement this way. If an expression's absolute value of an expression is less than k, then that value expression is trapped between negative k and positive k. Similarly for the less than or equal to sign. So let's take a look at on example 5. Solving absolute value of 2x minus 1 is less than 5. So we isolate the absolute value by itself already, so therefore it is okay to apply the equivalent statement. So let's go back a little bit up, right? So the statements say that this expression's 2x minus 1 will be in between 5 and negative 5 when the inequality is less than. Right? That's important. So now we know how to solve this inequality already. Right? So add 1 to all parts, so it'd be 4. Negative 4 is less than or equal to 2x less than or equal to 6. And divide everything by 2, that would be negative 2 is less than or equal to x and less than or equal to 3. So this kind of component inequality is easier to graph, which is my graph will be, here's negative 2, here's 3, and both of them is inclusive, and then the value of x is trapped between these two. Interval notation, smallest value to the largest value, which is negative 2 to 3, and use bracket, right, to indicate inclusive. Let's go to the next example. Solve. So solve 2 times absolute value of x plus 3 minus 4 is less than 6. So first we need to isolate the absolute value by itself before we deciding, right, which equivalent statement we need to use. So that means 2 times absolute value of x plus 3, adding 4 to both sides, which is less than 10. Divide both sides by 2, that will give me absolute value of x plus 3 less than 5. Now I can decide which equivalent statement I want to use, right? Because of this is less than 5, so less than indicate that the expression x plus 3 will be trapped between negative 5 and 5. And we subtract 3 to both sides, that will be negative 8 is less than x less than 5. And that allows us to graph quickly, which is the value of x is trapped between negative 8 and 5. Not inclusive, not inclusive, and here's my graph. Interval notations, its smallest value, which is negative 8, to the largest value of the solution set, which is 5. And both of them is not inclusive, so it will be parentheses, parentheses. Finally, the last part of absolute value inequality. So this time, we are interested in talking about the absolute value is greater than a number. So we know that from previously, if absolute value of x is equal to 3, that means what? I have these two solutions right here, 3 and negative 3. But this time, I want the distance to be greater than 3. So absolute value of x is greater than 3. So that means the distance from 0 to 3 from 0 to greater than 3. 0 to greater than 3. Right? So the value of x must be bigger than 3. So that tells us this portion right here. And on the left hand side, if I want the distance to be greater than 3, then the value of x must be negative 4 or negative 5 or something like that. So meaning the expressions must be less than negative of that number. So that's the part that you have to be careful. And then, most importantly, these two inequalities are connected by the statement or, right? Statement or. So let's go back. If the expressions, absolute value of an expression is greater than k, right? When the inequality symbol is greater than or equal to, then the expression is greater than k or expression is less than negative k, negative of that number. So like before, we're going to isolate the absolute value by itself first and then apply the equivalent statement. Example 7 is already given to you. Absolute value is isolated by itself. So we can apply the definition right away, which is 4x minus 13 is greater than or equal to 5, or it is very important that you need to write this or, otherwise we don't know how to collect the answer of the compounding inequality at the end. And the second part is 4x minus 13 is less than or equal to negative of that number, negative 5. So now we can solve each case. So it's very important that you write down the equivalent statement correctly on the first step, otherwise everything is wrong. So adding 13 on both sides, that gives me 4x is greater than or equal to 18. and divide both sides by 4 and then reduced it, which give us x is greater than or equal to 9 over 2. On the second inequality, add 13 to both sides. That gives us 4x is less than or equal to 8. And divide both sides by 4. That gives us x is less than or equal to 2. Since our compounded inequality is with or, like before, I'm going to try to visualize it. Here's 0, here's 2, here's 9 over 2. X is greater than or equal to 9 over 2, so it'll be going to this direction. And then the second one, x is less than or equal to 2, so it's going to this direction. Since the equivalent statement is using the compounding inequality or, that means my solution has to be all together of these two inequality solutions. So that gave us our final answer. The graph will be here, 0, 2, 9 over 2, going to the left hand side, or 9 over 2 closed circle going to the right hand side. Interval notation is writing from the smallest value to the largest value, so it'll be negative infinity to 2, and negative infinity is parentheses, 2 is inclusive, so it's bracket, union with 9 over 2 to positive infinity. And again, 9 over 2 is inclusive, so it'll be bracket, and the infinity is not inclusive. Finally, the last example. And this example, the absolute value inequality is isolated already, so I can apply the definitions right away, and the inequality symbol is greater than. So that'll be 3x plus 4 is greater than 2, or 3x plus 4 is less than negative 2. Solving each case, 3x subtracting 4 to both sides and dividing both sides by 3, that gives us x greater than negative 2 over 3. On the second inequality, again, subtract 4 to both sides and divide both sides by 3. That gives me x is less than negative 2. So don't forget to write down this compounded statement or, okay, because that's going to help us to collect the answer. So here is negative 2, here is negative 2 over 3, and open circle because it's greater than, so x is greater than negative 2 over 3, that will be going to this directions, and then x is less than negative 2, so open circle again and go into that directions. Yeah. So my answer is or, so we are combining these two solutions together, right? We want all the solution from here, so that will be this portion and this portion. So my final answer will be from negative 2 and negative 2 over 3, open circle goes to the directions, x is less than negative 2, so it will be going to the left direction. interval notation is from the smallest value to the largest value, so it will be negative infinity to negative 2, not inclusive, so parentheses, union with negative 2 over 3 to positive infinity. So again, negative 3 over 2 is not inclusive, so it will be parentheses. Infinity, we always use parentheses. That will be the end of the sections.